So welcome. This is the final defense presentation for the Urban Tree Data Asset Management for Kawartha Lakes. We are the branch and team. I'm Alison, that's Emmanuel, and Laura is online.
Hello, thank you.
Next.
This is a quick overview of our project dispersed with our client and the requirements and goals as well as the study area, our final deliverables, and our methodology of how we got everything done, and finally our moving forward stage.
Next. The project has been initiated for the city of Kawartha Lakes, the second largest single-tier municipality in Ontario by area. With a population of about 80,000 people living in around 30,000 homes, it becomes crucial for the Parks and Recreation Division to ensure a good quality of life for residents through activities like tree planting, pruning, removal, health assessments, watering, mulching, and some grinding or removal. Currently, the public must call in to make requests, which are then recorded on paper forms and organized into work orders before they can be addressed. This process is not only cumbersome but also runs the risk of losing public requests, leading to repeated requests for the same issue. Recognizing this challenge, the City of Kawartha Lakes, represented by James, sought an online solution to effectively manage incoming public requests for tree maintenance. This solution leverages Argus Online and a suite of applications, including Survey 123, Field Maps, Dashboards, Story Map, and Argus Pro. Next. Our study area is the entire city of Kawartha Lakes, having an area of about 3,330 square kilometers, with particular attention to urban centers such as Lindsay, Bobcaygeon, Fenland Falls, Ongini, Kirkgate, Kinmount, and many more. Next. The project workflow commences with the data acquisition and via tree points, which are subsequently stored as a separate layer within a tree database. Two key feature layers subsequently stored as a separate layer exist in this design. The CKL tree request for public data collection and CKL tree primary, which is the main feature layer storing all trees for the city of Kawartha Lakes. After verification by a professional, the points received from the public are copied onto the tree primary feature layer every day at midnight using scripting. The data is then visualized through a captivating story map for the public and an interactive dashboard for employees, empowering the users to delve deeper into the information. A tile-based map featured for the study area provides foundations layers upon which visualizations can be displayed. To ensure clear communication of the project's key findings, an infographic has been created along with a user manual for the solution. Next. To begin with, the client has no digital platform that stores the location and attributes of tree data. They have provided us with a high resolution of 0.15 meter spatial resolution of aerial imagery dataset to use for the extraction of tree locations. The imagery dataset is shown in the top left corner, and below it is the output with all the output of all the algorithms with all the iterations. In the middle, we've zoomed in over to our campus to get a better view of the outputs. And those are the tools that I run, which is detect objects using deep learning and extract features using AI models. The car detection and building footprint detection models were used to complement the tree detection model. The model arguments of the tree detection model is modified where the threshold, which is the confidence value, and the non-maximum suppression overlap. Next. This is a representation of outputs of all iterations from the tree detection model. As you can see, a lower threshold will return thousands of points which may not be the intended object. The top right image proves that the model performs very well for individual trees that are sufficiently far away from other objects. The bottom right image is a glimpse of the old tree data that the client has provided with the image. This data is outdated and has been updated using the image. Next. Here we can see the best output sorted according to the confidence score, where cyan is the least and pink is the highest. Confidence score is the probability by which the model thinks the output is accurate. It is a measure of the model's certainty on its own prediction. The values in this output range from 70 to 94. Next. Each object in selected iterations were manually verified by comparing with imagery provided, looking at it in points, looking at the points in Street View on Google Maps, and by eliminating objects that have a significant overlap over cars or buildings obtained from other models. Electric poles, empty patches of land, and tables are other detected objects that were misinterpreted as trees. Next. In the first iteration, 4,879 objects were detected, of which 4,826 were true, giving us an accuracy of 98.95%. Sorry, validity of 98.95%. And in the second iteration, out of 2,524 objects that were detected, 2,502 were trees and shrubs, which gives us 99.13% validity. And the other iterations with the outputs are also shown. Please.
So to be able to show all those points, we needed a base map, which was the first need of our client, was to distinguish private land from public land being land that's owned and maintained by the city. It included gathering parcel boundaries and also doing outside research and location correction of points and creation of points. ArcPro, and then it was packaged with a vector tile layer and added to the ArcGIS Online environment. Next. So first, I started with context. I used second-tier municipalities to create a larger base map than needed to show off the study area in the middle that's highlighted in the red. Next. Zooming in, towns begin to appear, the towns that I created in a feature class and labeled with XY coordinates as well. At every layer, there should be equal amount of detail and at every zoom layer. So beginning with smaller and larger towns, zooming into more specific road layers and smaller villages. Next. Looking closer, the green is the city-owned area and the gray is the public parcels. It's important to label the hierarchies correctly. So main roads are darker. Smaller roads are thinner and lighter in color. There's a halo on everything, as well as parts that are labeled in water. The areas of interest for the city were city-owned areas like landfills, firehouse, recreation centers, parks, libraries, things of that nature where they would have to do maintenance on regardless. Next. And this is a specific use case. This is the trail behind the Boys and Girls Club. At a glance on Google Maps, you can't tell who owns that. It just looks like a deer trail through some fencing. And I have first-hand account that it is maintained by the city. And so that's what this green layer is useful for, to show those unlabeled areas that are city property. Next.
Okay, the schema. As you can see, we have designed several tables to efficiently handle urban tree data. The main table are tree primary and tree requests. Tree primary stores detailed information about each tree, and tree request manages tree requests made by the public. The relationship between these tables are managed through the foreign key request ID. The tree request table is fed in two ways, with data queried by remote sensing technology, and also tree request is fed by the requirements made by the public. Let's see how it was built. Alison?
So the public interface was key to our client. It needed to be simple and user-friendly, as well as following all the CKL branding. This included making a custom theme in story maps. Next. This is the landing page with the Kawartha Lakes logo and their colors, as well as the Kawartha wave that we were required to add into any website they wanted to put on. Next. This is the welcome page, again using their branding images with that we have encrypted, which is just cool. Anyway, the navigation bar shows the important headlines and used for ease of navigation for people who maybe don't know how far they have to scroll or where they have to go for things. Next. There's also required a disclaimer on all of the parcel boundaries because there are inaccuracies and that nobody can take this map and call it fact and then use it to fight with their neighbor over parcel boundary disputes, as well as the building layer is not 100% and not up to date to like this year, so things are not as accurate. So there needed to be a disclaimer about that. Next. And this is the request status map. This will show the points, whether they've been defined or processed by the supervisor at the town. It only has request IDs and whether or not it's been processed or declined based on the symbology. There's no public information being shown on this, contact information or emails. Next. And finally, after a short description and instructions on how to use the survey, there's a link to the survey 123.
Accessing by the story map main website, we have the make a request survey was created by using survey 123 connect. This tool allows the public to easily make tree related requests. These are some screenshots of the survey demonstrating its friendly interface. Fields included in the survey are tree location. Notes contains the request reason and optionally contact information, and also the field status with domains decline it and process it. These values fields are integrated directly into tree request layer, allowing efficient and centralized management of the requests made by the public. Well, other fields like request ID, address, and ownership are calculated using Python script to run at midnight using task scheduler. Also, an email is sent to the supervisor with the list of new requirements. Then, um, then the supervisor will use these leads to using the validation request processes survey. This survey is used, as I said, by the supervisor to ensure the authenticity of the request before being processed on the fields. This survey is accessed by the supervisor using the supervisor dashboard. A status field is now integrated directly into the tree request layer, allowing the request to be seen by the field crew. The field crew uses field map to process requests that have been marked as processed. Field maps allows them to work both online and offline. Here you can see some screenshots of the field maps interface showing how field teams record and update information directly from the job site. At the end, they mark surveyor approval, and that is the trigger to allow the migration between a request and primary. The field team can edit various tree attributes such as common name and condition, and the team verifies all attributes on the ground before data is migrated to the tree primary layer. Finally, the process of migrating data from tree requests to tree primary, we use Python scripts to automate this process, ensuring that the data is automated and outdated and transferred efficiently and without errors. These automated tasks are executed daily using the Windows Task Scheduler. The result is an inventory of trees with all their attributes completed.
And finally, all of this data is displayed on the supervisor's interface as she will be the one who is going to validate these requests. It needed to be put aside from the ArcGIS environment because supervisors are not particularly trained to use that kind of software. And this is private sensitive public information, so it needs to have a bit of privacy and also, of course, on brand. Next. This is the splash screen. Again, another disclaimer. This has to do with the parcel boundaries as well as the responsibility of those who open this dashboard to keep the public contact information private. Should only be used by the supervisor or those of her equipment. Next. They requested total records as well as a list including the request ID, condition, surveyor approval, and contact information, as well as date created and date edited of each record. There is a processed or declined percentage as well as tree condition, just to show for interior display for the employees. Next. And this is also where she will find her link. It'll be separate from the ArcGIS environment where her survey 123 will be available as well as instructions. And finally, our poster, our infographic summarizing all of the work we did in an easily digestible way. We're going to use it as a deliverable for the client who requested it, as well as the poster for our open house. Next. There's some customization of symbols, as well as the line map creates a bit of a flow from the custom base map to the surveys. Next. And then down to the dashboard and the story map, as well as a little why we use it, why it's useful, and of course, following the branding, of course, will be good. Next.
We created this solution intending for them to use in the long run, and once they have sufficient points, they can run some spatial analysis and detect some species that are prone to particular diseases or wildfires, stuff like that. They can also get a better output of 3 points from using LiDAR imagery along with multispectral imagery. Next.
And that concludes. It's just a reference to questions. And the next
job.
Thanks.
Yeah. You made it through the hard part.
Only sweating a little bit.
Yeah.